So now today we start second chapter, chapter number 2, which is relations and functions. So before we define what we mean by a relation in mathematics, first I will introduce here one operation from sets, which is called cross or Cartesian product of sets. Cartesian product of sets. So let's see. Okay, so this is like operations on sets. You already studied union, intersection. Same way, this is also an operation on sets. So we take two sets, let A be a non-empty set and B is also non-empty sets. This be any two non-empty sets. Then they cross or Cartesian product that is denoted by this symbol. This is read as A cross B, which is nothing but set. It is again a set. So Cartesian product of sets is a set of all such members of this type A comma B. This is called an ordered pair, where this A comma B, this is combination of two objects, is called an ordered pair. Pair means two, and here order is important. That's why this is called an ordered pair. So A cross B is set of all ordered pairs of the type A comma B, such that where this A comes from A, so A belongs to A, and this B comes from B, so B belongs to B. This is the definition of cross product. So if you want, you can write like this: set of all ordered pairs of elements of sets A and B. This is A cross B. I repeat, what is A cross B? It is a set whose members are ordered pairs A comma B, where this first member comes from the first set and the second member comes from the second set. So in general, we can say that A cross B is a set of all ordered pairs of elements of A and B. That's a definition. This is a new set obtained from the given two sets. Like this is called an operation. It's like union, intersection, and so on. For example, if I take similarly here B cross A, if I write, so it is a set of all members of the type B comma A, such that B comes from the first set B and A comes from the second set A. Your order is important, remember, the way the objects are taken. This ordering is important. The first member should come from the first set, second member should come from the second set. So clearly you can see that A cross B need not be same as B cross A, remember. These two sets need not be equal. You recall these two were equal. Recall A union B where B union A intersection B equals to B intersection A. But here A cross B need not be same as B cross A. That's true, remember. Such operation, if you remember, where these are equal, that's called commutative. So this is non-commutative. Cross product is non-commutative. Okay. Now here we can write cross product of the three sets also. If I have three sets, for three sets A cross B cross C. This is called the cross product of three sets. Their set of all ordered triplets A comma B comma C. This is called a triplet here. Combination of three objects. So first member comes from the first set, second member will be from the second set, and third member will be from the third set. This is called an ordered triplet. Remember, A comma B comma C is order triplet. So A cross B cross C is a set of ordered triplets of the members of the three sets, where A comes from A, B comes from B, and C comes from C. This way we can generalize for any number of sets, but in general we have this A cross B cross C. Now we note 2-3 things about cross product. The first one, if A is empty or B is empty, if any one of these two is null set, then A cross B, obviously it would be empty, because to form the cross product you need member from these as well as this. If at least, for example, this is empty, then you cannot form any ordered pair here. So A cross B as well as B cross A, both are always empty sets, remember. Second one, if number of elements in A is, for example, small m, number of elements in B, for example, n, like this has m elements, this has n elements, then number of elements in A cross B, that is number of ordered pairs, it will be product of these two, that is m into n. For example, if A has, let's take A equals to, suppose I have 1, 2, and B equals to, for example, I have, let's take A, B, C. So A has here 2 members, B has 3 members. So if I find A cross B, now we are forming the ordered pairs. So I'll take one member from here, 1, and one by one all the 3 members from here. So 1 comma A, 1 comma B, and 1 comma C. Similarly with this one, 2 comma A, 2 comma B, and 2 comma C. So you could form 6 ordered pairs. These are the possible ordered pairs, A cross B. 1 with A, 1 with B, 1 with C. 2 with A, 2 with B, 2 with C. So 6 ordered pairs. A has 2 members, B has 3 members. So here number of elements in A is 2, number of elements in B 3. So number of elements in A cross B equals to 6. So you have 6 ordered pairs in this. Now if I find B cross A, so B has here A, B, C, 3 members, cross A has 2 members, 1, 2. So if I find this here, cross product, A with 1, A with 2, then B with 1, B with 2, then C with 1, and C with 2. 6 ordered pairs again. A with 1, A with 2, B with 1, B with 2, C with 1, C with 2. This is B cross C. Now if you see here clearly, here one object is 1 comma A, which is not in this. This is A comma 1. Both are different, remember here. Positions are important. So clearly A cross B is not equals to B cross A. So this was second remark. Now if I go to third one, that usually if you have your A cross A, we write as A square in sets. If you have A cross A, we write usually as A cube. So A cube means cross product of A with itself 3 times, and A square means cross product of A with itself. So this is A cross A, which is A square, A cross A cross A, which is A cube. So now next, if I take R as a set of real numbers, set of real numbers, then R cross R, which is called sometimes R2. And by definition, you know, all x comma y, where this x comes from R and y also comes from R, so xy belongs to R. This is nothing but set of ordered pairs of real numbers, remember. So you know this is called a coordinate plane R2, coordinate plane, or just a plane or Cartesian plane, two-dimensional space, you know, like this. There's x-axis, y-axis here. This is set of real numbers. This is also set of real numbers. Here every point is represented by two ordered pairs. If I take this point, then again it is represented by two coordinates. So here every point is nothing but combination of two real numbers. So this Cartesian plane is nothing but just R2, two-dimensional space. Usually we call that as 2D. This is in general referred as 2D, two-dimensional. Now same way, if we go to R cross R cross R, that is R3. This is called three-dimensional, 3D. So that is set of all ordered triplets x comma y comma z, where each x comes from R, y comes from R, and z comes from R. So here each of these is a real number, set of real numbers. This is called 3D or space, three-dimensional space, three-dimensional space. That is what usually called 3D space. There every member is represented by three components, x, y, and z. In R2 we have two axes, coordinate axes, usually called x and y. So there every point is represented by two components. So here it's like this. This is x-axis. This is just set of real numbers. This is, for example, y-axis. This is again set of real numbers. This is z-axis. So x-axis, y-axis, and z-axis. So every point P has three components, 1, 2, and 3. These are called coordinates, x coordinate, y coordinate, and z coordinate, like this. This is called origin, you know, here 0, 0, 0. This is called origin, you know, here 3D. And here this is origin, which has two components, 0, 0. This is in R2. So that R2, that is coordinate plane or just a plane, which comprises of two axes, x-axis and y-axis, where every point has two coordinates, x and y. In R3, three-dimensional. It was two-dimensional. So there every point has three components, or these are called coordinates, x, y, and z. This is called three-dimensional. X-axis, y-axis, and z-axis. These are the three perpendicular axes. You know it probably. And further also you'll learn about 2D and 3D, two-dimensional and three-dimensional. Now we go to first exercise 2.1, which is very simple exercise. The question number 1, you are given two ordered pairs. Ordered pair x by 3 plus 1 comma y minus 2 by 3 equals to this. Find the values of x and y. That's the first question. That I'll do. Look at it. Question number 2. Set A has 3 members. Set B has again 3 members. So find the number of elements in A cross B. So it's obviously 3 into 3. So you'll have 9 ordered pairs in A cross B. You know it. Then this is also too simple question. You are given two sets G and H. Find G cross H. So you will have 7, 5, 7, 4, 7, 2. Similarly, 8, 5, 8, 4, and 8, 2. So you will have 2 into 3, total 6 ordered pairs. And then similarly H cross G. Question number 4 here. P has two members, Mn. Q has two members, Nm. Then P cross Q. So 2 into 2, obviously you should have 4 members, sorry. You should have 4 members here. If I mention M comma N, M comma M, N comma N, and N comma M. 4 members you should have in P cross Q, but here you are given just 2. So the first statement is false. You are asked to check whether the statement is true or false here. So first one is false. Second question. A cross B is a non-empty set of ordered pairs such that X is in A and Y is in B. So obviously this is true. This is definition of cross product. What is A cross B? Is a non-empty set of ordered pairs X comma Y, where X comes from A and Y comes from B. So second one is true. Third one, if I go to third one here, what is the answer to B intersection phi? You know from set theory this is phi, and A cross phi gives you phi, so this is phi, therefore this is again true. Okay, now further let us see. So question number 1, these two ordered pairs are equal. Just we need to recall this. Recall two ordered pairs A comma B equals to C comma D implies double ways. In fact, first equals to first, that is A equals to C, and second equals to second, that is B equals to D. This is always true. A comma B equals to C comma D if and only both ways. First equals to first, second equals to second. So here we use this concept. So this equals to 5 by 3. X by 3 plus 1 equals to 5 by 3. And y minus 2 by 3 equals to 1 by 3. So if you compare, I'll take LCM here. So x plus 3 by 3 equals to 5. 3 will get cancelled. So x will be 2. And here if I take LCM, 3y minus 2 equals to 1. 3 will get cancelled. 3y minus 2 equals to this. So 2 on the other side, therefore y equals to 1. These are the values of x and y. So A is this, B is this. You want answer to this one. A cross B intersection phi. A cross as it is. You know B intersection phi is always phi. You know, very standard property, A intersection phi is always phi. This much you know. Intersection of null set with any set is null set. And now cross product of set A which has two members, but phi means it has no members, so you cannot form any ordered pair. So this is phi. Just recall the remark. If you recall the remark, you know that A cross phi is always phi. So therefore this statement is true. This is a true statement. Now I'll go to fifth question. Question number 5. There A has two members, minus 1 and 1. And you're asked to find A cross A cross A. Triple cross product. This is the question. So what we do? We find first A cross A here. A cross A. You know A has two members. So A cross A would have 4 members. So minus 1, comma 1 cross minus 1, comma 1. Cross product with itself. So minus 1 with minus 1. Then minus 1 with 1. Then 1 with minus 1. And 1 comma 1. These are the 4 ordered pairs in A cross A. And now we find A cross A cross A. So what do we do? With this A cross A, you write again that set which is minus 1 comma 1. Now this you know, this has how many ordered pairs? 4 ordered pairs. So 4 into 2. So total you will find 8 ordered pairs. So with each ordered pair you are going to combine minus 1. and with each ordered pair you are going to combine 1. So 4 plus 4, 8. So I just write here, your members will be ordered triplet, remember. Minus 1, comma minus 1, comma minus 1. Combining this with minus 1. Minus 1, comma 1, comma minus 1. Combining this with 1, comma minus 1, comma minus 1. And last one with minus 1. So 1, comma 1, comma minus 1. I just repeat, I'm sorry. Minus 1 here, minus 1 with this, minus 1 with this, and minus 1 with this. And same way, each of this is combined with 1. So minus 1, minus 1, 1. Minus 1, 1, 1. Then this with 1. 1, minus 1, 1. And finally last with 1. So here 1, 1, 1. So this way you will get the total 8 ordered triplets here. A cross A would have 8 ordered triplets. So here you are given A cross B in the question number 6, that consisting of 4 ordered pairs, and you are asked to find set A and set B reverse. So which is very simple. A would be set of all members which are at the first place. So A, B, B. But you cannot repeat the members, so it is just A, comma B. All elements which are at first place. And set B would be obviously X, Y, X, Y. So it is just X, Y. Repetition is not allowed in a set. So 2 members here, 2 members here. That is 6. Question number 6. Go to question number 8 now. There you are given a set which consisting of 2 members. The another set B, 3, 4, 4 members. This is given. Write A cross B. So the first question is A cross B. So you know 2 into 2, 4 members. 1, 3, 1, 4. Then 2, 3, 2, 4. So there are 4 ordered pairs in this. A cross B would have 1, 3, 1, 4. 2, 3, 2, 4. 4 ordered pairs. Now further, how many subsets will A cross A have? Now next question is to find number of subsets of A cross B. This is the next question. Now again you recall from sets, as number of subsets is given by number of subsets, that is equals to 2 raised to n, where this n is number of elements in a set. So here number of subsets equals to 2 raised to number of elements in A cross B, because you are finding number of subsets of A cross B. So you need to see how many members are there in A cross B. A cross B has how many members? 1, 2, 3, 4. So 2 raised to 4. So you would have 16 subsets, remember. Number of subsets of A cross B would be 16. This is not important, but just I'm telling you, like if I list some of them, this is just for your information. This is not asked in the question. One subset is empty set. Empty set is a subset of every set. Then you can take singleton 1, 3. Then you can take singleton 1, 4. And so on. So that way you form the total 16 subsets. So total 16 subsets. Listing is not important, remember. This is not important. Important one is this total number. This just for your information I have suggested. Subsets 1 is empty, then 1, 3, then 1, 4. Then you can 2 members, 1, 3, 1, 4, and so on. Finally A cross B itself. That is also there, A cross B itself. You recall from set theory, every set has at least 2 subsets. One is itself and the other one is empty. That you know very well. So total you would have 16 subsets. 2 raised to number of elements in a given set. So here number of elements in A cross B, because you are finding subsets of A cross B, which is 4. So 2 raised to 4, which is 16. So in the 10th question, you are given that A cross has 9 members. and you are asked to find, you are given one more thing, that -1, 0 and 0, -0, 1 both are in A cross A. This is given to us. Remember, given that A cross A has 9 members and these two ordered pairs are in A cross A. The question is, find the set A. This is the question. What is set A? So here obviously -1 is in A, 0 is in A, and 1 is in A. So therefore A has these 3 members. -1 is in A, 0 is also in A, and 1 is also in A, remember. So A has 3 members. Now you are asked to find remaining members of A cross A. This is also you are asked. 2 members are already given. You are asked to list out remaining. So remaining will be 7. We'll have remaining 7 members. So here remaining members, you can take this -1, -1 itself. Then -1, second one with 0, which is already there here. It is given to you. Then -1, 1. And then next I'll start with 0, 0, -1. Then 0, 0. And then 0, 1, which is already given, so I'm not listing. Now with this 1, -1. 1 with 0 and 1, 1. I repeat, 1 with -1, 1 with 0, and 1 with 1. So these are the 7 ordered pairs in this. The other 2 already listed. Total, A cross A would have 9 members. So this is a cross product.